In the last two videos, we saw the most fundamental types of combination questions: order matters and order doesn't matter. So now, hopefully, you will see that for the remaining questions, they are all just very slight variations on those two fundamental types of questions. So this question here is an order doesn't matter question, but with subgroups. And this question is really just half a step up from what we did in the last question. So this one says 10 opera singers are trying out for a choir with 5 open spots. 7 of the singers are altos and 3 of the singers are sopranos. The choir director has stipulated that the 5 spots must be allocated to 3 altos and 2 sopranos. How many different combinations of singers can be chosen? So to start, the first thing I always like to do in combination questions, well, the very first thing I do is I ask, does order matter? And so in this case, if I'm ever confused, and once in a while, it can be a bit unclear if order matters or not, I will literally think, like in the last question, what am I doing? Am I running a race or am I picking a team? If I'm running a race, then order matters. Picking a team, order does not matter. Here, we're just picking a team. So order definitely does not matter, which means I have to get rid of repeats. Now, the second thing I usually like to do is I like to just write out the pool of people I have to draw from. So in this case, they say I got 7 altos. So these are nameless, faceless altos. So I'm just going to make 7 A's. 1, 2, 3, 4, 5, 6, 7. And then I have 3 sopranos. So that is my pool to choose from. And then I got 5 spots. However, these spots are restricted because I must have 3 altos and 2 sopranos, which means the one thing you wouldn't want to do is you would not want to say the answer here is just 10, choose 5, because I have 10 people to choose from. I gotta choose 5, because that would not be taken into account our restrictions. And in fact, if we were to do this, I would guess one of the trap answers is going to be this. So 10 choose 5 would be 10 factorial over 5 factorial times 5 factorial, which would be 10 times 9 times 8 times 7 times 6. And so here, the 2 cancels out with the 6. 10 and 5 gives you a 2 up here. 8 and the 4 gives you just a 2 up there. And so what do we got? We got 14 times 18. What is that? 252. D. So this is the one answer you would not want to choose. So if we are taking into account our restrictions, what is our restriction? Well, it says 3 of our spots must go to altos, and 2 of the spots are reserved for sopranos. So you can think of this almost like we are picking 2 teams. We are picking one team of 3 altos and then one team of 2 sopranos, and then we are putting those 2 teams together to form a 5-person team. And so we got to calculate these separately. So how many ways can I choose my altos? Well, you have 7 altos, and we are choosing 3 of them. So that should just be 7. Choose 3. Then for our sopranos, we got 3 sopranos, and we are choosing 2 of them. So it's good to be a soprano because you get a higher probability of getting chosen. So if we calculate these individually, how many ways can I choose my alto? So 7 choose 3 should just be 7 factorial over 4 factorial times 3 factorial. And that is just 7 times 6 times 5. Everything after that should cancel out my 4 factorial. So I'm just left with 3 times 2 times 1 3 times 2 is 6, so that cancels out this. I got 35 ways I can arrange my altos. What about my sopranos? That is just 3 choose 2, and this is a nice shortcut that you can use anytime that you have a blank choose blank, where the left side is just one more than the right side. The answer is just your left side. So 3 choose 2 is 3, 4 choose 3 is 4, 100 choose 99 is 100. If you want to actually do this here, we could just be 3 factorial over 1 factorial times 2 factorial, which is just 3. So we got 35 ways we can arrange our altos, 3 ways we can arrange our sopranos. Then what do we need to do with these two numbers? Are we multiplying them or are we adding them? And so for that, we talked about this a little bit in the last video, but I think we have a better scenario here to explain it. Let's say my altos, I got 7 altos. Let's say that's person A, B, C, D, E, F, and G. Then my sopranos are X, Y, and Z. So if you think of this as we're taking one team of 3 altos and one team of 2 sopranos and putting them together, well, then you can sort of visualize whether or not we need to multiply or addition by saying, let's say we chose A, B, and C. I don't need the slots here. A, B, and C are my altos. Well, I don't care about just the 3 altos I choose. I only care about unique 5-person teams. And so these 3 altos can then be paired with either XY, XZ, or YZ to form a 5-person choir. And so what this means is for any 3 altos that I choose, you sort of have to multiply your total number of combinations by 3 in order to give the number of 5-person teams that can be made from them. And so that is why here we are multiplying, we are not adding. So 38 is not the answer, because we are saying any of these 3 altos that we choose can be paired with any of these 3 sopranos that can be chosen to give us a unique 5-person team. So 35 times 3 should be our answer. 105, which is B. But the real point is, if you can do this, and I like this notation, this blank choose blank, because especially for more complicated combination questions, as far as I am concerned, if you can get to this point where you just write, oh, the answer is 7 choose 3 times 3 choose 2. If I was working with a student and they got to that point, I would say, good, done, we can move on. Everything else after that is sort of just don't make a math mistake. If you can just get this setup, though, that shows that you understand combinations. And so we will do some more of those in the next video.